8.2. We talked about exponential decay and we kind of flew through this lesson because it's such a repeat of 8.1. But before we go into just using the formula for it, we're going to review a few things. How can you tell if something is a growth or a decay? And remember, the really key is the number that is raised to a power. If that number is greater than 1, that's a growth. And if that number is in between 0 and 1, then it's a decay. So if we looked at example 1 and they asked us to determine, we look inside the parentheses. 2 over 3 is a less than 1, so this becomes a decay. 3 over 2, it's 1.5 is greater than 1. This is a growth. And this last one, we said that there's two ways to do it for you to know how it looks like. Either you remember that 3 to the negative x can be written as 1 over 3, all to the x. You just flip the sign. So it becomes a fraction. Clearly, this is the decay. The other way to do it is just graph it, because when you have a growth, it starts small and it goes high. When you have a decay, and we're going to graph quite a few of them, it starts high and it goes low. So if you graph this one really fast and it starts high and it goes low, that makes it a decay. If it starts low and it goes high, that makes it a growth. That's kind of how you can identify them. The other thing we did, and I'm not going to cover all of the examples because you know how to graph now, is we learned how to graph them and then determine domain and range. As we told in 8.1, the domain is all real. We don't have to work about that. It's just working on what is the range. And the decays work the exact same way as the growth works. I'm going to put it in really fast. 1 divided by 2 all to the x plus 2 plus 1. And I'm going to go ahead and do a zoom 6. I'm going to graph this. And if you remember from last lesson, I told you that really this tells you what's going on. I have a y and I have a 1. And I just need to know is y greater than 1 or less than 1. And if you look at the graph, clearly this function goes to the bottom. I don't know where to put it. I don't know why it's doing this to me. Anyways, you get to see it. So, and because it's going down to the bottom, then I get all of the y's being less than 1 because the function doesn't go up at all. So for my range, y is less than 1, and we are done. That's how we graph this. And that brought us directly to modeling with a decay function, okay? And the modeling looked exactly like, of the decay, it looked like the growth. But remember, this was 1 plus r there. We now have 1 minus r there. Initial amount, rate of growth, rate of decay, or decay rate. I messed up here. Decay rate. And then we said that the thing in parentheses 1 minus r is called a decay factor. So you're going to have homework that's going to ask you to identify the decay rate, which is just how fast it drops. And then the decay factor, which is 1 minus that rate as a decimal. And we have an example 4. And we talked about this a lot, that there's things in your life that are going to be assets and some that are going to be liabilities. A car is that liability. So it talks about a car that brand new was $24,000. Right? And it has a decay rate of 16% or 0.16 each year. And they're asking you, the first thing is to write the model. This is your model. Don't stop there because you can do that subtraction. So this becomes 24,000 times 0.84 to the t. And you need this model because you need to graph it every single time. I just realized that we skipped the whole part of the other problem, but we'll do this one, and the exponential growth one works the exact same way. Here's your model. Then they also ask you, use the model to estimate the value after 2 years. So all of a sudden, t becomes 2. So you go y equals 24,000 times 0.84 to the second power. And you just plug this in your calculator, and it's going to be about 16,900 something. Okay? So if you look at this, you started here, you ended up $7,000 less. And this is just reality with cars, but cars are necessary, so we're going to drive them. Some cars depreciate slower, and you get more value out of them, and some drop prices really fast. The second part that we didn't do for the other one is graph that model. So we went into y equal, and we put that in, 24,000, and then it's going to be parentheses 0.84, all of it to the x. And this is the part where we played with our window big time. Okay, we went into the window. This is a real life problem. X is minimum is 0, x maximum can stay 10, it's just times. But my y minimum is 0, and my y maximum it's pretty clear. How much did we pay for this car? 24,000. That's the max that the y will be, right? And now I'm going to go graph directly and have that graph done for me. And here it is. We've done it in class. That's for your point B. And for point C, it says use the graph to estimate when the car will have a value of $12,000. We said we're going to use the option trace on it. And then we're going to move that to the left. In my case, I don't know where your little dot will come until it gets very close to $12,000. Here I am. I'm right about there. And for my y being 12,000, my x is 4, right? So in about y is $12,000 in about 4 years. So you only get half value for your car in about 4 years after buying it. So anytime you graph them, anytime you need to find a value, please remember the trace button. You go up and down until you find your y, and that's going to give you x. And that, friends, was 8.2. Happy homework.